GM's PLM leader and was also supporting the integration of General Motors Systems Engineering Organization into the PLM environment. Probably most important, Craig was supportive of INCOSE, where he authorized representatives of his companies and the other industries to engage and discuss the engineering process. And GM had technical specialists that taught us a lot about how the big scheme of engineering and manufacturing come together. So I think right now Craig is probably at a campground somewhere in the state of Michigan, and that after his presentation he will be serving pancakes for all that can get there on time. How's that, Craig? Audio?
Ah, there we go.
Maybe?
Now you can hear me, right?
Good. Thank you. We hear you.
Pancakes, hot dogs. It's a little warm at the campground today, so I apologize for that. Is the audio okay? I'm just doing a check.
You're good. You sound good.
All right. Well, so welcome everybody. I'm happy to fill in for Don, and I'll just give you a bit of an overview here, and then we'll get started. So this is Don's background. Most importantly, at CIMdata, he's our practice director for simulation-driven systems development. So this is more than computer-aided engineering and classic modeling and simulation. This is, in fact, the integration of systems engineering into all of that. And so Don's background, you can read about. Some of you undoubtedly know him. Certainly Mark and Don work well together on different initiatives. And Don and I work together at CIMdata with various clients, from solution providers like an ANSYS or a Siemens, to even some other larger industrial companies, but I tend not to focus on aerospace and defense. There's other people at CIMdata that do that many people have met. Rather, we go to discrete equipment companies or car companies or even a few others that are using more and more electronics. Don joined CIMdata in 2013 after years in the solution provider side of the market. He's active in many things, including INCOSE and this forum, the GPDIS. Some of you are probably aware of the Aerospace and Defense Action Group. We're going to talk a little bit about that before I end here. And they're doing a lot of good work. Mark and the team at Boeing are a part of it, and I couldn't be happier with what they do. Some people have asked me why the automotive companies don't do that, and frankly, that's a story for another day. So, and you heard a bit about me, and thank you, Mark, for that wonderful introduction. I am retired, in case anybody's wondering, and so I do this part-time, and Don and I especially have been poking at MBSE and the EDA world quite a bit this past year, and I'll share some of that with you. So I'm going to present a bit about what CIMdata believes is what's going on in the market, and so I think that's part of your questions are, you know, what's the market developing into, and we'll talk about that. Your earlier conversations today and the importance of MOSEC, among other things, really talks about the digitalization trends, and frankly, I'll just skim over that rather than take your time repeating some of it. And then I'll focus a bit on what's the role of MBSE. As Mark knows, I have strong opinions about where it should go inside of products companies, whether you're defense-driven or whether you're commercial-driven. But also, it's much broader than where it started, which was this ability to do this initial product planning or contract planning if you were a one-of-a-kind thing. So we'll talk a bit about the role and how it's changing. And then we'll talk about interoperability challenges. Now, like I mentioned earlier, I don't want to repeat what's already been said today. I'll just acknowledge from a market analyst point of view, this needs to be solved, this interoperability challenges. And I have some survey data. It's a little bit old. And and I'm happy to report that some of the problems are being addressed by the solution vendors, and I'll summarize that. And then, well, what's going to happen next? And I'm really pleased, though not interested, but I am pleased that the previous discussion just happened, because one of the issues that gets in the way of using digital tools is the whole contracting practice and how do we manage contracts. And I remember, and Mark, I have to think about this, but I think we were both at a PLM World Conference, or maybe it was Realize Live when Siemens took it over a few years ago. And when we were there, the question came up, why aren't the solution vendors doing more? And I think we had a pretty heated debate about, the real issue is we, the OEMs, have to make it a requirement, or in the case of government contracting, the procurement agents need to say models need to be a part of the contracts, and they need to be clear what it means, and it also needs to be able to change throughout the life of the contract. So I'm pleased that discussion's happening. I think that is one of the biggest challenges. I also think really good partners, wherever they are in the supply chain, really do want to work in a model-based world, and MBSE can help that. Okay, and then a few concluding remarks. So there's emerging complexity, not just in the technology we all want to implement, but also in the way we want technology to be a part of our lives. And so this complexity is increasing, and it's going to keep increasing thanks to Moore's Law and a bunch of other things that are happening. Today, early in my career, I dreamed about having data at my fingertips that I could make better decisions, and now I've almost got the opposite problem, where we have so much data at our fingertips and so much machine learning that I'm getting overwhelmed by it all. This is the new normal, and we have to figure out in our systems how to manage this complexity. Of course, digital tools are the opportunity, and so it'd be nice to find the market intersection of how much upfront cross-domain engineering do we do versus how much risk mitigation do we do. And of course, somebody's going to figure it out, and the companies that figure it out will be the successful ones. Digitization is driving major trends. MBSE used to be talked about in small groups of people. I was a part of a team of 4 people at GM that got asked this question a long time ago, over a decade ago. Well, should we? Because they knew about it from other domains, and there was an interesting discussion about it. It is about connecting voice of the customer and requirements, system level design, modeling, and simulation across all domains. And I emphasize all domains because it's going broader than engineering. That's part of what we'll talk about today. So these other trends are happening too, and I might argue you can't have a meaningful digital twin if you don't have model-based system engineering, and I'll let that sink in as we're talking here. By the way, the benefits of simulation, what Don points out here is the democratization of simulation. It's here. People that are not simulation experts are able to use simulations interactively to make better decisions. This is really, really good, and it will make for safer products. Okay, so there's a lot of talk about digital twins and digital threads and even digital cloth. This is the definition we use at CIMdata. And it's much broader than this notion of a single physical mock-up that we somehow make a packaging decision on. Rather, it's this whole communication framework that allows the data to be connected. Thanks to cheaper computers and cheaper disk space and all other kinds of technologies around databases, we have more and more data. Every one of these little bubbles on this picture has its own data, and getting them to manage their data, whether it's the data in mechanical design and PDM, or simulation and load cases, experience design, if you will, in SPDM, or even those guys off in the embedded software world, which we call application lifecycle management. They all have their own ways of managing this. The digital fiber, if you will, wants to be the way it's all interconnected. And MBSE can help bring some context to a point in time of those connections. And so it's really important, and nicely the technology is evolving. Now this picture has ERP on it, which talks about mass production, but there's another bubble I could draw, which is the whole service world. It's kind of in the upper right-hand corner, but some companies make all their money at the service side of this. And so can you imagine using MBSE to improve the service experience, meaning either the operational uptime or even the ability to diagnose a problem more quickly? And I'm sure the leaders in aerospace and defense are already doing this. They've probably been doing it for a while in certain areas. But it's going to become common. It'll be the common way we do engineering to think about service and operational life from the beginning. The earlier discussion about DevSecOps it's good the discussions are happening. So we have a classical systems engineering V, and a lot of it's, it's a folded waterfall, is what I like to point out. The team there at Boeing, they came up with a better model, which I really like, because, the digital thread is about exploring inside out. It's about the assets you have and the things you want to do, and using modeling up front to help with design, and using simulation at the back to help with the delivery or verification and validation. So, pictures are important to set your mental image. If you're thinking a simulation just replaces a physical test, while that's true, you're limiting yourself to what else it could do. And so I think these pictures help a lot. And, the V helped organize terminology, and it's still needed for engineer to order kind of systems. But when you start talking about reuse and product line management and the ability to share knowledge, the diamond picture on the right is much better. And MBSE is at the center of that. So let me share some market results. So CIMdata does this. This is part of our research arm. And we collect feedback from mostly solution vendors, and they tell us about their revenue actuals. And then they give us a forecast of the next year. And for time reasons, I'm just going to show you the actuals from 2020. And as you might expect, some things went down because of the pandemic. What is surprising to a few of us is what didn't go down. And in fact, if I showed you the forecast, you would see that they beat their forecast. And so it's the two outlined in red, which is the topic for today. But I want you to sneak down to the next two and also realize the EDA, so the way we define electronic design automation, and then the AEC is architectural and engineering, so it's civil engineering or the building of buildings. So notice how big those got, and we think more and more it's clear to us that the pandemic caused increases in these areas. And so as a systems engineering team and a model-based system engineering, where do you think your future customers are, or at least the ones that have growing money? From the solution vendor's point of view, it's the bottom four. Okay, so keep that in mind as we keep talking. Is there an MBSE market? Well, yes, is the answer to that. And I know Don said, well, it depends. I think the classical, really good MBSE engineer who knows Modelica and SysML and some of the other trade-offs, has been a part of the standardization effort, you may be frustrated that there doesn't seem to be a market. Part of the problem is MBSE is not understood by people that have the money that want to improve a company. They will listen to us when we talk about it, and they'll say, well, put it in terms of my metrics so I know how it's going to improve my business. But, I can remember for years at GM, we argued about trade studies and FMEAs, and the point was, well, once we got really good at a four-cylinder engine, why would we do any of that anymore? Because we're really good at it, right? And so you got to caution this discussion or temper the discussion about MBSE with where is it really useful? Well, look at the legacy. It's really useful for brand new systems where you have to manage risks and maybe explore a new way of doing something. It becomes less useful if your product line never changes until, and this is my premise, is that until you start thinking about that service life cycle and the way customers are actually using your product and the way they're failing, the way they need to be maintained, and so on. So in addition to the list that Don's mentioned here, start also thinking about systems engineering from a service point of view. So here's our forecast. We published this back in June for 2021. We'll update it in the winter time with the actuals. We'll see how close we are. But again, I would encourage you as we recover, so look at the middle column, as we recover from the pandemic a little bit, we see revenue growth everywhere, but the big ones are the bottom four again, with one other exception. So I would say MBSE wants to be interested in all of those, not just be called the tool category other, but rather talk about, well, how does it affect EDA, electronic design? How does it affect simulation and analysis in general? Maybe bringing context beyond the initial engineering part of the project. And then I think, and I'm seeing an example in automotive, where the AEC connection will even begin to matter. You might say, well, how could that be? I think when you get to autonomous vehicles, some of you in defense and aerospace know this, you're going to need to share information from the different vehicles so that you can improve the overall safety of the operation of any participant in the grid of machines running around autonomously. So the way you configure a city, the way you configure cameras, views, other things, so that you can share that with people participating in the environment will matter more and more. It takes MBSE to help manage that. So I think there's this broader market, and at the moment it's not its own row, and we'll see over time if that changes. So model base, what's the business challenge? Well, part of the business challenge is we've got, in this picture, we got 4 domains, and we wonder how they're going to work together. They all need to be supported. It's more than just physical mock-up like we talked about with static visualization. And even in software development, a control system, you'd really like to see motion virtually. You'd like to see motion done poorly, right? If maybe there's some vibration in the system that you're trying to control. When you learn something from the field, so up in the behavioral modeling and simulation side of it, you want to immediately put that back into your models and then ask the question, does this new understanding change anything we were planning to do in the next iteration of the product? This idea of constant feedback will be more and more likely thanks to MBSE. And of course, all the solution vendors they have great stories about some of this. Some of them are worth your time. Some of the rest, you just need to evaluate them and find out how real they are. The fact that people are talking about it so much is an indication to me that a market is developing. And this notion of models, in Mark's original talk this morning, he touched on, the creator of the model knows its usefulness, right? Knows where we can use it most often. While I fundamentally agree with that, you want to encourage people to use your models, though, and to understand that context, and then let them explore a little bit on how else could they use the model to make other decisions, right? Maybe a fundamental behavior model of the way a system operates can also influence a maintenance procedures, right? Even though the model author didn't intend that. So you got to keep an open mind, but then remember the principle about models, they're all bad, some are useful, right? This is a famous phrase made. All models have limitations, whether they're economic models or mechanical engineering models or control system models, and you have to know the weaknesses of the model in order to use them well. So we got to think about how do we communicate that. Part of that's in the metadata that was mentioned earlier today. So how do we connect MBSE and the digital thread? We've been touching on a lot of these, and what's really exciting to see happen is that the platform providers are doing things. Some are making acquisitions, others are making partnerships. The classical CAE platform providers are venturing into system engineering more and more. Even the major EDA vendors are sticking their nose into SE and even CAE, it turns out. And so if you haven't paid attention to what Cadence or Synopsys, and for you guys, unless you're in the control system avionics, you probably don't know what I'm talking about, but you should go take a look. These guys are pushing into systems engineering because what they developed over the years is a simulation engines that can handle millions and millions of test vectors. And their point is that same problem wants to be solved by MBSE people, right, where you can evaluate hundreds of thousands of test cases efficiently over and over and over. So it's an interesting value proposition. I think they're onto something. Remember what I showed you in the market share revenue numbers? They're the guys that are growing the most. And then finally, the ERP people, they won't be left out. They'll have something to say. Just like they did for PLM, they'll probably have something to say with MBSE, but I would remind them, you know, that's not really their forte, so they just need to figure out who on this list they should partner with. We as OEMs and tier 1s and 2s, we should influence that. We should make it clear what we want. So what are the trends, and how is this helping address the challenge? Well, linking to IoT especially, and then linking the electronic embedded software world more and more with the PLM world, you know, it's a theme in every OEM I study. It's what I spent 10 years doing as well. We used to be limited by investment in IT hardware and IT software, and I think now we're really limited by just how much more sensing can we consume. The sensing, the Internet of Things kind of sensing in a factory is becoming pervasive, and as we all know, it can be pervasive in our products as well. We've heard today about MBSE data exchanges and interoperability standards. That's really important. It really brings the context of a twin to a particular point in time, right? It's more than just visualizing a mock-up. It's also seeing its dynamics, or seeing even field failure data in the context of a 3D mock-up can help you make better decisions. MBSE can bring some of that context. There needs to be more work done for modeling and simulation and SPDM tools. You know, there was a big debate a few years ago about SPDM and PLM, and they would all get together. What I think the mechanical PDM side underestimated was, well, what else do you manage in simulation besides the geometry and the mesh and the results? Well, it's all the load cases that go in, and they come from everywhere. It's unstructured data oftentimes in order to go out and harvest what are the meaningful load cases. So there'll probably be necessary islands, and I'm a big fan of figuring out how to integrate the islands, not one island consume another island. So that leads back to interoperability standards, and we should do this as fast as we can, because what's at our doorstep, it's already happening, is forms of augmented intelligence, right? Where parts of the simulation data are made visible, and then that view is shared with many people, even those outside of modeling and simulation, and you want to make sure that people make informed decisions, not irrational decisions based on a model. So setting the MBSE thread, the challenge, and again, some of the presentations earlier today did this pretty well. I just want to give you a picture that these different circles, if you will, the tops of silos, have got to figure out how to do model-based design, and have to figure out how to connect with these other worlds. And I think it goes beyond just the point of manufacturing and mass producing, but also the whole service cycle. You know, I'm currently working with the CIMdata team with a vendor outside of aerospace and defense and not automotive. And what's interesting is understanding how they use bombs, and bombs are all in Team Center. And then I got to a question about, well, show me a virtual representation of that piece of equipment. And they're like, oh, that's over in some other system, in the PDM system. And so if your bombs are not talking about a visualization of the product, a simulation of the product, then you know you need to go fix that so that then MBSE can encompass all of this. I think the values are becoming clear. The question is really training enough people to know what it is. That's part of what we're doing here. And then also getting the PLM vendors to appreciate what it means to be MBSE and PLM, how they go together. This is a little bit old, and maybe Mark and Don will take my aged comment here and update the survey. But in 2018, this forum, they did a survey, and roughly 60% of the issues were interoperability issues in technology. Now, I'll tell you, the technology's fast going away. And so if it's interoperability issues continue, it's an issue around standardization and not around, is there a tool out there that can do it? But the other 40%, and of course if the base is changing, this hasn't improved as much as I would like, right? 40% are related to strategy and the people and the processes. I have this little memory from my early days in automotive. My first 10 years were in aerospace. And I got to a place where the electronics were being developed, and they had the most state-of-the-art hardware in the loop system. I thought, well, this is really cool. I didn't really realize they were using it. And then I got to the engineer in charge, and he said, oh, why would we use that when we could just go build a car and take it for a drive? And I'm like, oh my, we've got a long way to go in the organizational side to embrace even electronic hardware in the loop, and this is a few decades ago, everybody. So this is an example of the organizational changes that have to happen. The people have to wake up and realize there's a new way of doing business, and it actually lowers risk, okay? So I would like to encourage GPDIS and maybe the GPDIS, excuse me, and also the A&D Action Group, maybe take on and do a survey in 2022 and compare it, because you'll see some of this red and pink has started to go away. And what still is an issue is maybe it won't be unknown standards. It instead will be not embraced yet standards. Anyways, that's a prediction. This is a model that Don uses to show how things could evolve and the things that have become de facto standards. And I like to just point out, when something becomes a de facto standard, there's a reason. Oftentimes, it's a real-world problem being solved quickly. And then the one that I'd like to comment on here is the one around Arcadia and Capella, which I was only really getting to understand as I retired, and I've seen it evolve over the last few years quite nicely. So if you're convinced, the MOSEC discussion we had earlier about it needs to happen, right? It's highlighted red, and AP 243 is highlighted red. They need to become de facto. And we need to continue the discussion about how do they become de facto like these other things. This was from that same time period, and take a look at what the challenges are, the red items. Again, I suspect what we're going to find if we do the survey in another year is that many of these integration points have gone away. The limited vendor support will be very different, I'm sure. But are OEMs and suppliers using models together? Do the contracts encourage that? Do they enable it so that there's no nickel and diming on change orders every time you change the requirements database? I could just imagine that the headaches growing. And then this other thing about skills, the fewer trained modelers. Well, I think we're doing okay on the number of authors. What we need to talk more about is the number of users. How do I use an MBSE model in my existing process, or better yet, how do I change my process to take advantage of those models? And this is a standards roadmap, which I think I'll just skip over. We've talked a bit about that. So I want to get to this A&D group, and so this is just a collection of references for the different standards, and it's a progress report. I'll have to find out from Don when he captured this list. But to those listening, feel free to use that at your will. One of the ones that we have spent some energy on is the MapleSoft product, which is intriguing. There's also other collaboration efforts underway to integrate data and processes. And so Sodius is one of your sponsors. I've worked with them over the years. I got introduced to the OBO folks, a couple conferences ago, and I'm intrigued by their solutions. I'm seeing that they will be needed for things like autonomous vehicles collaborating together in a city, making sure nobody runs into each other, right? No crashes. So those are just a couple examples, and Don's listed the others here. Okay, so in the few minutes I have left, and then we'll have some time for questions, I want to talk about the opportunities a bit more. So because it's becoming so much of a commodity, the ability to buy some machine learning bandwidth, if you will, from somebody like Amazon, suck in a lot of your data, and then start looking for patterns that you may not have been able to find before. This deep learning, machine learning is becoming more and more available. And because it's available, the artificial intelligence is improving. And so MBSE could augment this human decision by helping organize this digital pattern matching, if you will. That's really what deep learning is. It's just going through piles and piles of haystacks, finding needles. You need MBSE to help decide if the needle is important, right? So I think this is eminent. I think actually some of the companies that are doing the machine learning so well, I'm really talking about Amazon, Google, Facebook, and the rest, they have things where MBSE could benefit, and also it'll improve the view of the product lifecycle, the whole lifecycle. Now, I think Jim might be on the call, but Jim Roche is our CIMdata director for the A&D practice. And if you are not aware, you can ask one of these member companies what this is all about. But just let me highlight it from a MBSE point of view. So several work teams have been formed over the last few years, and the one that Mark and Don lead is the MBSE one. Okay. And part of that's evaluating current practices. And when we get to Q&A, if you got a specific question for this area, I'll probably ask Mark and Jim to help me answer it. So they captured the current state of the A&D industry. I'll give you a moment to read through that. It's very clear here in 2021, the couple of the big PLM solution vendors really do have a pretty well integrated MBSE solution. Sometimes not with the most favorite authoring tool, but they still have very capable systems. That last point's important. But architectural modeling remains a weakness, right? And we'll talk a little more about that. So they established an MBSE vision. I've read it. I agree with it. If you haven't read it, you should take the time to do that. And here was their problem statement. And the project objective they took on was to evaluate and promote methods. What Mark summarized for you earlier today is partly that work, I'm sure. And pictorially, it comes after, these two areas of design requirements and behaviors, they're going along pretty well. We've all got our favorites. But this whole area of architecture is poor. And I mean, it's done by experts in companies, but as far as an industry standard that you can build cooperating tool sets around, that needs attention. This is back to the V diagram. I think I'll go past that. And then there's a summary of these languages, and you'll note at the middle is Capella. So if this is the first time you've heard about Capella and this company named Thales, I ask you to go spend 30 minutes reading, and I guarantee you'll spend another 3 hours after you spend 30 minutes. So it is an open source thing, so it's interesting. You can start using it. But beyond being open source, it really is solving this architectural problem. To the credit of this A&D work group, they realized that, and they included it in the interoperability study, which is great. Here's the results in calendar year 2020. And these are links that you can find. All of this is managed on the CIMdata websites as a part of the A&D Action Group. And with that, let me get to concluding comments, and then I'll answer questions as best I can. So, you know, the model-based market continues to expand and evolve. And, you know, a big question we often get, and we especially have been having the debate with the EDA community, is, you know, where's the analysis tools for EDA? Are they in EDA or are they in S&A as we segment the market? And the answer is it's muddy. It's a little confusing. But this whole thing about model-based system engineering, model-based everything, you know, it's becoming clear that maybe we had better think about how we've partitioned these things, because with these smart connected products, there's more and more of them. It used to be just really expensive airplanes and engines and elevators, and now it's the car you drive, right? I mean, we car guys monitor stuff in your car. You allow monitoring through your cell phone. So this onslaught of data is helping companies make better decisions. But how do you put that field data in the context of meaningful context so engineering can make decisions, right? The spending continues in PDM and CAE, and it will, because it makes companies more efficient, okay? But they don't know how to buy MBSE, and they're hearing about it. They hear groups like us talk about it, but because the first word is model, they oftentimes think it's just another CAE tool, and I think that's just where we are. The growing application areas and how we'll apply MBSE, well, especially AI and machine learning, it's going to explode. And so I'm more and more convinced as an analyst and as a retired professional that educating folks what it is, what it might be, and how it's going to become pervasive thanks to the commoditization of all this machinery around AI, it's going to change the way we engineer products going forward. And so the universities that understand what I just said, this is great because you can train the next workforce. So the ones that didn't, I think you need to go do some more homework. I think it's coming. Product innovation platforms and model-based engineering, it's not the end. And I think before long, we're going to talk about model-based life cycles, and the engineering up front, and then the re-engineering in the middle, and then the re-engineering as it continues on for 20 more years or 50 more years of its product life. You know, management support, new processes and people and skills are critical to success, and I think it's this group that's listening today, part of what we need to do is help management understand how it's a different skill, but at the same time, you know, not try to boil the ocean, look for those quick wins and take advantage of, you know, if the AI team is struggling with setting context, they're overwhelmed with all this data, but they can't choose the needles, just point out to them, well, MBSE could probably help. Let's talk about establishing context. And so with that, I'd like to thank you for your time. And Mark, I think we've got time for a few questions. And somebody famous once said, the only thing we have to fear, it's fear itself. And so let's just get on with it. We're going to figure out a way to use MBSE. And for sure the big OEMs and the governments will benefit, and everybody else will benefit as well. Solution providers aren't the constraint. If there's a constraint, it's our ability to adopt it. So just keep that in mind. Thank you, everyone.
Oh, Craig, thank you very much. That was pretty enlightening. And we do have a couple of questions. So on chart 15, back in your presentation,
okay.
You
remember it's Don's chart, but keep going.
Okay, that's all right. They're numbered down on the bottom, and 15 comes right before 16. Okay, very good. So you imply that MBD, and this is not 3D model-based definition, this is model-based design, the behavioral mathematical capability. In many of the system design communities, they view them as separate yet integrated, that is MBSE and MBD. And they use different tools. Can you make a remark on your perspective of MBSE versus MBD?
Yeah, probably not, but here goes. When I first presented about model-based systems engineering, I asked people, how do you make decisions? And sometimes they would say, oh, well, we have a model of fuel economy of across the fleet, and that tells us what the mix of vehicles we want to produce is, at least in the car business. This is something that's a regulation. And so we use models to make decisions about our systems. And I said, oh, well, then that must be model-based systems engineering. The design word in the car business, at least, means 3D geometry of a mechanical part, right? And so model-based design can oftentimes mean the thing that you're going to mass produce. Whereas model-based systems engineering, the example I gave you was what the collective of all of the products in the market are going to produce in terms of a fuel economy average, right? So they're different is the point in my answer. And it really matters that you understand what it is you're wanting to talk about. I agree with the picture that MBSE includes model-based design, but a lot of times model-based design is driven by, I'll call it the nearer term decision you're making. If you have to invest, one more example, if you have to invest in tooling in a plant, your model-based design is probably about how do I design the part so that I can produce it at the whatever the line rate is, right? So I got to think about the fixture. I got to think about whether I'm bending it or milling it or molding it, things like that, right? So model-based design is using models to make those decisions for those near-term decisions, where I think model-based systems engineering is broader, and you know it unfortunately got equated with that broad problem for system architecture before there was architecture models, and so the languages, both Modelica and SysML, they kind of went off about solving that problem, and now not so much anymore, but for a while those languages were equated to MBSE as one and the same. And I don't like that. I much prefer a very broad models that help us make decisions is model-based system engineering. So I hope I answered the question.
No, that's good. It's a good perspective anyway. So let's see, I got one more question. So you shared information that described the marketplace and that we clearly see revenue growth in the tools supporting the development of MBSE models.
Yep.
But what about the other side of the equation? Does the industry have the skills and the people available needed to create and use the models? Generically, these are STEM skills, but based on my non-scientific observation, the tools and data standards are not always part of the university curriculum in today's environment. Isn't the potential for revenue growth connected to the shortage of authors and users?
It's for sure connected to the shortage of users because they don't know other than they learn it along the way. They didn't learn it in schools, unfortunately. There's a couple schools now addressing systems engineering as a practice or as a discipline. I think the new constraint, we should do the survey over and find out, but I think the new constraint is going to be exactly this. We don't have the skills, and we haven't, or I should say many companies have not adjusted their development and service processes to take advantage of MBSE, and I mean that broad MBSE. You know, this adage that I shared with you about, well, let's just go build one and take it for a drive. You know, the way we took that argument apart was we asked them, well, what's your build variation? Oh, we just send it over to that shop across town that builds one-of-a-kind race cars, and they're really good at it. Yeah, and the variation of that part doesn't represent anything like mass production. And so what we were able to show, the simulation guys now, we were able to show by using those prototypes, they were actually making poor decisions because the vehicle they were testing was much better built than anything we'd get off a mass production line. So I think real-world examples about the benefits of models and using models to make better decisions is needed. And I think this skepticism about, well, we didn't understand all the physics, and so the model can't be good. You know, with one of the CAE vendors, we've been having a good, healthy discussion about the topic of meaningful models. A model can be meaningful at one point in time and less meaningful later, until you find a known unknown that you really didn't understand, and you get some field data that gives you some insight, okay? And then you get the insight, and you're like, oh, well, we could go model that. Can you imagine configuring a physical prototype to go do what you just learned in the field? It would take months, maybe a year. Whereas sometimes when you measure data or you're given more constraints, you encourage some invention that you might not have otherwise considered. And I think MBSE can help with that problem solving. And so maybe we should be teaching it as a problem solving skill, an evolution of design for Six Sigma or something like that, rather than other techniques we've had over the years. Yeah, skills improvements needed, users especially. Authors, you know, what I would say to the authoring community, you know, you're pretty good at what you do, but just get out of your comfort zone and go talk to the people that are having real world problems and ask yourself, are my models able to help them? I think you might consider evolution of your models in ways that will be better for service. At least that's what I predict. Anything else? I don't hear you, Mark.
I'm sorry, Craig, thank you very much for being with us this morning and being able to support in Don's absence, and we really appreciate it. And so right now we are in a break. My chronological tabulator says that it is 9:57. We will be back in 8 minutes at 10:05. And let's see, that is 1:05, I guess, if you're hanging on the East Coast.